Hello everyone, my name is Eric Jones. We are going to look at a lecture entitled Reading a Landscape and Irrigation Plan. And basically this is going to teach you pretty much to read any type of construction plan, especially related to the green industry. It's a class I show to my first year design students and construction students, and it's basically just to orient you with the plan. I'm sure most of you guys have already installed irrigation plans or installed irrigation jobs based on the plan, but some of you may haven't. So this will just kind of read over it. This talks about landscape plans and irrigation plans. This is kind of a short lecture. I think there's only about 17 slides, so it may not go the whole hour. Therefore, on the quiz, I'm going to have some math problems based on a plan that I've done for one of my classes. So you'll actually open up the PDF, and it's all dimensioned. I don't think you'll need a scale for it. If you do, I'm sure you guys probably have some scales. If you don't, I recommend having them anyway, both an architect and an engineer scale. And then you'll have some questions involved about that plan. So again, let's go ahead and get started. This is entitled Reading a Landscape and Irrigation Plan. It's been approved by the North Carolina Irrigation Contractors Licensing Board for 1 hour of, let's see, irrigation hours. So we get some irrigation hours here. So landscape plan reading. Reading and interpreting landscape plans will allow you to, one, understand the overall intentions of the landscape designer and what his final or her final results will be. It can be done by a landscape architect, it can be done by a building architect, and it can be done by a landscape designer. And I know there are some certified irrigation designers out there, so you may be seeing plans with those. It's going to help you identify the types and locations of materials that are specified by the design. You're going to be able to see which type of plant material the designer's calling for, what type of paving materials, what type of grass, or if it's sod, what type of mulch, if it's a hardwood mulch, if it's brick chips, if it is a pine straw, pine needles. It's going to indicate which type of irrigation heads that you're going to use for the job, type of irrigation controller. It's going to specify pretty much everything that the designer wants on his or her job. It's also going to identify the location of items such as the backflow, such as the irrigation controller, and the locations of each head that's throughout the property. You're going to be able to estimate the quantity of materials needed to complete the construction project according to the design. So you'll be able to figure out how many linear feet of pipe, how many heads are on the plan, how much square foot of seedings to be done, how many cubic yards of mulch you may need, how many cubic yards of concrete that you may need. And I find that a lot of my students, we actually have fun with it. You know, in some of the lectures we teach of construction estimating and figuring out the volume of concrete, and figuring out the volume of mulch, or the volume of brick chips that you may need for a property. My students really, by the end of the semester, their first semester, are pretty good at estimating some of these landscape jobs. And that's what we'll do for the quiz that you'll take on Moodle after this. Some common elements of landscape plans. You're going to have the title block, and that could be actually at the bottom of the drawing. It could be on the side of the drawing. It just depends. It could be on the shorter side, on the side, or at the very bottom. That just depends on the designer. You're probably going to see a lot of pre-printed drawings. And it just depends on who, what type of clients you're working for. Are you going to be installing plans that are drawn by hand, or are you going to be installing drawings that are done with something like AutoCAD, RainCAD, or even Pro Landscape? It just really depends on where they're going to put the title block. North arrow, it's always going to show you where north is, which way the house is oriented to north on the site. So you'll see the north arrow pointing towards the north direction. You're going to see a legend. Legend is going to include, well, you'll see things. Well, you'll see your plant list maybe over to one side, but in the legend you'll also see, who drew it, the date, drawing one of how many drawings, and things of that nature will be included in the legend. You may even see some different types of symbols that you will see on the plan included in the legend. And then again, the good old specifications. If you've heard some of my other lectures talking about specifications, we all can get in trouble. I've been in trouble with it myself by not reading the specifications. And it depends on if you're working for if you're working on installing a plan that's designed by a landscape architecture firm, or if it's a one-man or one-woman show, the specifications might not be as thick. But if you're working for, installing plans from larger firms, they're going to have specifications that could be as thick as a telephone book. And, not necessarily saying that the landscape or irrigation specs are that thick. You would want to definitely pull out the landscape and irrigation specs for the property that you're working on. And then again, the drawing scale. And if you've seen the other lecture, tools for design, what is it called? I can't even remember. Tools of landscape and irrigation design. You saw me talk about the good old scales here. Here we have an engineer scale. And, we have 20 scale on here, and basically what that's representing is 1 inch equals a foot. Flip it over, there's your 10 scale, your 30 scale. Flip it over this way, you'll be able to see your 50 scale, your 40 scale, and your 60 scale. With our scales, the most common scales that we're going to use in the landscape industry is going to be 10 and 20. Anything gets smaller than that. I have seen some landscape architects use 30 scale, which is 1 inch equals 30 feet. And when I say 1 inch equals 30 feet, that's meaning 1 inch on paper is equivalent to 30 feet on site. So we've shrunk it down by a third, basically. With an architect scale, our two common scales that we're going to use on the architect scale is going to be 1/8 and 1/4. I prefer 1/8 scale. Pretty much I can get most of my designs on a 18 by 24 sheet of paper or a 24 by 36 using the 8 scale. Quarter scale is going to blow it up. And when I say quarter scale, again, I'm telling you that 1/4 of an inch, so literally 1/4 of an inch, is equivalent to 1 foot on site. So 1/4 of an inch on paper is equivalent to 1 foot on site. So you could see that the 1/4 inch is going to be a fairly large drawing, and that's probably the largest you would ever draw in. And here we have 8th scale, and from here, guys, we have 8th scale and architect scale on the same lip of the ruler here. So when I'm reading my 8th scale, I'm going to start at 0 here, and I'm going to read left to right from your perspective. So the 1/8 is starting over here, so I'm reading 0 this way for 8th scale. If I'm reading an architect scale, I'm going to start over here, and I'm going to read right to left. And that's probably one of the most confusing things that happens with my students is getting them confused. Sometimes you may find a scale that only has 1/8 on one side and then 1/4 on the other side, but this gives you all the other scales on here. So here we have 1/8 and 1/4. Here you have 1/2 and 1 inch. You have 3/32, and you have 3/16. Here we actually have just a good old regular size ruler. And the other one that's on here, you have 3/8 and 3/4, and you also have 1.5 inch and 3 inch scale. So that is the architect scale. I keep both. These will actually fit in my pocket. I actually have some really thin ones, but this is a good little size to keep in the field. And as you can also see, with my larger ones, I've actually had the larger ones here, guys, and this is from back when I was in undergraduate. And as you can see here on my 10 scale, you can barely see the numbers. I've rubbed the numbers off, and it gets to be a little difficult to see. I've put these good tools to use, and the numbers have actually wore off. So, but you can pick those up at any office supply store, very, very cheap. Title block. Well, that's a collection of information often displayed in a box or a rectangle, and that is at the very bottom of the drawing, or it could be off to one side, going in a vertical direction. Again, located at the bottom or the side, it can contain some or all of the following information: the project name, the project location, the client's name, the designer's name, the sheet number, the consultant's name, the date, the sheet title, and the drawing scale. And again, going back to the drawing scale, it's talking about which scale that you would use to measure the design or the irrigation on the plan. As you can see here at this bottom of the top, the title block, this is actually a planting plan, and it's actually sheet number 1 of 9. So in this total design package, the architect has drawn on 9 different sheets of paper, and the first one is called a planting plan, and it is sheet 1 of 9. We have the scale here. We have some other information about it. We have the name of the landscape architect, who also does site planning, gives their address. It shows who the client is, and this is for Parker Community. This is actually in Colorado, and it actually doing it for the Neighborhood Homeowners Association. So all that information is based on there, and that is there in case you, as the installer or contractor, has any questions. You can call the designer, you can call the actual client. Most of the time, you're probably going to see this landscape architect on site, because it sounds like a pretty big project here, doing this xeriscape garden. North arrow. This is a graphic symbol with an arrow or indicator that points to north. It's used for orienting the plan to the construction site, and may be drawn in many different ways. It may just be an arrow with the letter N pointing to it. It could actually be done very, very graphically, and actually drawn pretty neat and pretty very detailed. Just depend. I've got some students that'll just draw that circle, throw an N on it, and just call it done. Then I'll have some students that will spend 20-30 minutes on doing their north arrow details, just because they're very, very particular. But the main thing is that it is going to show us where north is on the plan. Here we have just a schematic planting plan. Here within the legend is basically is the planting plan here, or your plant list. But as you can see here, we can see that this little sketch is 20 feet by 20 feet. Sometimes you will see the dimensions here. The designer or the architect will actually do dimension lines for us, and you'll definitely see it like on a residential construction home plan. You'll see a lot of dimensioning. Not necessarily with the landscape plan, but here we have a garden that is 20 by 20, which is going to give us 400 square feet total area. We can see the scale. The scale is drawn, is actually written 1/4 of an inch equals a foot, and it's also drawn graphically representing the scale. So if you actually laid this out, you could I've seen guys actually, they don't have a ruler with them or anything. They'll cut that out and they'll lay it on the plan and kind of figure out what the distance is between some of the trees and other entities on the plan. But it's shown graphically as well as written out for the scale. You see the north arrow where it's pointing. So north is directly straight up on the plan. And then within the legend, you can see that T represents a tree that's 10 gallon. S is representing a shrub that's 5 gallon. GC is representing a ground cover that's 1 gallon. A is representing an annual that's 4 inches. And then OC is plants that are planted on center. So we can look up here and we can see that we have 3 trees. It's pointed. We have 3 T's. We look down in the legend and see that we have a trees. We have 6 S. We can look down here and see that the S is shrubs that are 5 gallon. So we can go 1, 2, 3, 4, 5, 6 shrubs. Then we have 7 GCs or ground covers based on the legend here. So 1, 2, 3, 4, 5, 6, 7 ground covers. And then at the bottom right hand corner of this schematic, we have 39 annuals. A representing annuals that are 4 inch and they are 8 inch on center. So that'll tell you exactly how many annuals that we have there, and we have 39. Again, the plan's 20 by 20, and I know this may seem like basic information to you guys because you're probably looking at it every day, or you could be doing your irrigation plans. We had a guy that worked for us several years that would go out with some flags. He'd mark the heads, and next thing you know, he's getting the trencher off the truck, the trailer, and there's trenches being installed. So you may not do a plan. But there may be opportunities or situations where you have to follow the plan, and sometimes just being able to read the plan and taking a refresher on it. Again, I introduce this to my students each semester. The first lab they're going to do is to read a plan and read a scale and read a tape measure, because they may have forgotten over Christmas break. They would definitely have forgotten over summer break. So we touch on it and refresh ourselves. And then there's times, guys, that I get such a complicated plan that I feel that the designers have put too much stuff on it. It would have been easier to create a second drawing, especially something that's done in CAD. File, save as, another drawing, and kind of clean it up. I don't like seeing it all cluttered, but just depends on the designer that's doing it. Instructions and requirements that must be, or plan specs, are instructions and requirements that must be followed when implementing the landscape design and or irrigation design. You got to follow the specs. So for us, being irrigation contractors, we're reading the plan. We see that they're wanting a Rainbird controller. They're wanting the i5000s. Well, that's what's on the plan. That's what's in the specs. Or maybe the plan doesn't even say it. It's specified in the specification. So what you're seeing is a solid colored circle or a solid colored triangle that's representing a head or a pop-up location on the plan. Well, you're Mr. Rainbird guy. I love Rainbird. I love Toro. I love Hunter. 3 great companies that produce products for us, and there's some other good ones out there. I would never knock any of them, but let's say that you are Mr. Rainbird. You've been certified through Rainbird to install. You're 100% dedicated to those guys, and you see a plan done by an architect, and you go ahead and start installing Rainbird irrigation parts. Well, what if the landscape architect had specified Hunter? It wasn't on the plan, it was in the specifications. You got to read those specs and make sure that that you know what's to be installed. The designer has their preference. Again, if you've seen my previous lectures, it's okay to talk to the designer or the architect, and definitely talk to the homeowner, because he's definitely the one that's paying. But 9 times out of 10, the architect is representing the client. You may or may not talk to the client. The designer's acting as the management company between you and the owner. He's representing the owner. So if he spec'd out a particular brand of controller, or a particular brand of heads, that's what you're going to install. It doesn't matter that you're only used to installing a certain brand. You've got to go by the specifications. There's horror stories of that out there, and if you watch some of my other new lectures of this year, we've talked about that, especially when it comes to wire baskets on trees. But the specs, they're intended to ensure a quality of level of construction. You have to install it by the specs. And again, this comes to whether or not taking the wire baskets off a tree, is my horror story I told earlier. It often includes guidelines for the product selection. Again, hey, they may be specifying Hunter when you want to install Rainbird. It's going to talk about site preparation, excavation. The specs may call it, guys, if you open up a trench to lay irrigation pipe, you may have to close that trench before you can go home. There is no taking taking orange cones out there and stretching off some yellow tape. You may have to cover up the trenches every evening. Maintenance requirements. You may be required to maintain that irrigation system for 1 year at your cost. The specifications will tell you that. I have an instance here, knew of a company, good friends of my dad, that bid on a job, a new apartment complex down in the big old town of Charlotte. They got the job, and they were installing the plant materials, did everything, got it installed. I mean, this was a huge job for them. It was an apartment complex. So it wasn't just one building, it was several buildings with several units in it. So it was a healthy, meaty job that they should have made great money. Well, their estimator did not read the specifications. He pretty much got, the plan figured and the estimate right, but what was included in the specification was that the installer was to provide 1 year maintenance contract that is supposed to be in their final bid price. So let's just say, we'll take small numbers to keep it low. Let's say they did the job for $20,000, the total project. I'm sure it costs more than that, but let's say it costs $20,000 to install. Well, it was going to cost an additional $15,000 to mow it and everything for 1 year. So that would have been $15,000 plus the 20. He should have submitted his final bid for $35,000 instead of 20. He screwed himself out of the maintenance contract. They had to take care of it for 1 year because it was in the specifications. So basically, they ended up losing money on the job, whereas they could have actually made a good profit if they'd have just read the specifications. It's going to talk about the planting techniques, or the guying of trees. And one thing it's going to mention about the guying is that either you're going to stake your trees or not, but it's also going to tell you who's responsible for taking off the guy wires and when you will take off the guy wires. It may be the maintenance contractor, or it may be the installation contractor coming back so many months later to remove the guy wires. Read the specs, it'll tell you. It's going to talk about mulching. Do you mulch it 4 inches thick, or do you mulch it 3 inches thick? It's going to talk about the cleanup. It's also going to talk on cleanup. You must clean up at the end of each day. And then, last but not least, but probably one of the most important things I think when it comes to irrigation and landscaping, is that we don't necessarily take the time to do good soil preparation. Using the correct soil amendments, using peat moss, soil conditioner, and things like that, and actually prepping the beds and prepping the soil will actually help us as irrigation and landscape contractors. Soil science and plant science, guys, are big things in our curriculum at the school I teach. It's our bread and butter. It's our 2 freshman classes that if the students don't get right off the bat, they're going to have trouble throughout the 2 years that we have them. Here is a plant list that you would actually see on a typical landscape plan. You're going to have the key, which is going to be the abbreviations. You may also see symbols here. You may actually see the actual plant symbol, but here, they are representing a Fraxis Americana autumn applause, or autumn applause ash. He's representing it with the abbreviation of FAA. It is, here you will see the quantity. There's 2 of them on the job. There's the botanical name, there's the common name, and then there's going to be the size and planting method. It is 2.5-inch caliper, that's B&B, and remarks. It should be 5 trunks with full crown. Those are your shade trees. Here he has ornamental trees. We have some evergreen trees. We have our deciduous shrubs. So a very detailed plant list here. And basically, guys, when you're looking at a plan, you can do your estimates from this right here, but I can tell you from experience doing the O'Reilly's Auto Parts that, let's take for this columnar English oak. What I've seen here is that the quantity on the plant list might show 8, but accidentally the landscape architect left off 2 more on the job. So I always count per plan. If I see that there's 8 of these columnar oaks, I'm going to find each one of these on the plan. And what I do is I take a pack of colored pencils, or I take some highlighters, different colored highlighters, and I will find all 8 of these oaks and I will highlight them so I know that I've accounted for them, because I'm not going to eat 2 more, because basically the plan's going to overrule what's in the plant list. The architect's going to say, well, there was 10 on the plan. Yeah, that was my bust. I put 8 in the quantity. Those 2 more you're going to have to eat. Always double check the quantity of plants on the plan compared to what's in your plant list. Here we have the drawing scale, and a tool that we're going to use whether or not we're designing or installing landscapes or any type of construction type plan. But the drawing scale, it specifies the relationship between the distances on the plan and the actual distances on the site. So again, remember I was talking about a 1/4 inch, a literal 1/4 inch of a foot on paper is representing 1 foot on site. That's for architect scale. Talk about engineer scale. If we're saying 1 inch is equal 10 feet, that's meaning literally an inch on the paper is representing 10 feet actually on site. So scale is often shown with a scale bar marked off in inches or fractions of an inch. And here we see that 1 inch is equal to 30. So if we were to actually take a regular tape measure and measure over an inch, it's representing 30 feet on site. And here they've represented it graphically, and they've done it 15 feet here is half of it, the 1 inch. So 15 is represented by 1/2 inch. 60 feet will be represented by 2 inches. And they are shown as equivalents or ratios up to 1 to 600. We would never actually see one that big, but that's talking about when you're getting into machining or mechanical engineering. Good thing with us, and what I tell my students, I always try to tell them, estimate just a little bit higher. If something's 29.5 feet, go ahead and say 30. You want to give yourself that margin of error. And when it comes to lengths of irrigation pipe, if it's 6 more inches or if it's 2 feet more inches, I mean it's not you're not going to lose the job based on that. So scales for measuring our plans. An architect scale. This is used for architectural units. The distance is read in feet, inches, and fractions of an inch. It's used for residential properties, usually because the lot sizes are a lot smaller. We're going to use engineer scales more for big commercial properties. If you drew a 6,000 square foot lot in 10 scale, it's going to be a little bitty drawing on a big sheet of paper. So for residential properties, you're definitely going to be using a 1/4 or 1/8 scale. Engineer scale. For plans drawn in decimal units, the distance is read in feet and tenths of a foot, used primarily for commercial properties. And then metric scale, we're definitely not going to see anything in metric for landscapes. I saw on Instagram earlier today, it was talking about the metric scale. They said there's only 2 types of people that use metric scale, and that says that country, well actually there was I forgot. But what it was basically saying, there's only two types of countries that use the metric scale. One's countries that have been to the moon and countries that have not been to the moon. And they were talking about us. Since we had been to the moon, we are not using metric scale. The only time I use metric scale is in the Army and doing land navigation. So I know a little bit about it, but I would not want to use the metric scale for doing landscape plans or irrigation plans. I'm trying to think if anything on here, guys. With the engineer scale, if you can see my mouse moving around in between the 3 and the 4. Now this right here is 10 scale. I can just look at it by telling, but this would just say represent 1 inch equals 10. 1 inch equals 10 feet. So the 4 is representing 40, the 5 is representing 50, and then 6 inches is representing 60 feet. And what you can do, if you're confused on an engineer scale, you can always count each tick mark. So that's 30, 31, 32, 33, 34, 35 feet, 36, 37, 38, 39, and then that's 40 feet. So within engineer scale, and especially we use primarily 10 and 20 scale, if you're still a little bit confused, you can count each individual tick to find out how many feet is represented on the plan. And most of the time, 90% of my students are going to understand the engineer scale before they do the architect scale. One, you can count the ticks to get the number of feet. Second, there's only going to be one scale per side of the triangle, versus the architect's going to have one starting left to right and the other one starting right to left. Estimating for landscape plans, it's a process of calculating the quantities of materials and construction costs associated with a project. Quantities estimates are based on measurements taken either on site or directly from a plan. And then quantities allow cost determinations for materials, labor, equipment, and subcontractors. So, guys, what I try to tell my students to do is break down the plan into geometric shapes that we know we can find the square footage for. Circles. What's the square foot of a circle? It's pi times r squared. Pi being 3.14 as a constant, always and forever. R represented the radius, so the radius would be half the diameter, and you're going to square it. So if a circle has a diameter of 4, the square foot of that is going to be 2, because the radius is half the diameter. So 2 times itself, 2 times 2 is 4, times 3.14 is going to give you a square footage of over 12 feet. So here, well, we're talking about lineal calculations, but here, when you're figuring the lineal calculations, you're going to do all 4 sides. But to get the square footage, it would be length times width for this rectangle. But to figure the lineal calculation or the perimeter, it would be P along an edge or combined edge. So this is saying P is 2 times the length, 1, 2, and then 2 times the width of 1 and 2. Or you could just go by and add all 4 sides up together, and that'll give you your perimeter of the bed. But to calculate the square footage of this rectangle, it would be simply length times width. The lineal calculations we're going to use for edging and irrigation estimations, because we're calculating linear feet of pipe for our calculations. Area calculations, my favorite. We spend a lot of time with this in my construction classes. But they measure, it's a measure of a surface within a closed boundary. Again, length times width here gives you this the square footage of this. It's a number of ground cover plants or quantity of sod. It's expressed in square units such as square inches, square feet, square yards, and cubic yards. Here is our basic geometric shapes. Again, the rectangle, the triangle. The area of the triangle, seriously, is just 1/2 times the base times height. Here is your height. Here's your base. So multiply the base times the height, multiply it by 1/2, and that is going to give you the square footage of the triangle or area of the triangle. Here we have a parallelogram. We have area times base times height. I have a tricky test question here at school that gets students every time on this. We have the base times the height. Here you have the top and then the base. Well, this is your trapezoid, I'm sorry. And the area, this would be 1/2 times the base. Whoops, whoa here. We have 1/2 times the base plus the top. So half of that times the height will give you the area of the trapezoid. Back up to the parallelogram, we have the area is equivalent to the base times the height will give you the square footage of the parallelogram. Here's the good old favorite one of mine, circle. Area is pi r squared, so r is radius, and we have pi, which is a constant of 3.14 times the radius squared. Area calculations for irregular shapes. Now, we may have to figure this out. What if we're doing square footage for irrigation? I know a lot of guys that go out and measure the square footage of the turf, and they come up with a square foot price for their irrigation. Whether or not that's good or bad, that's totally up to you guys. But what we can do is figure out the square footage of these odd shapes fairly easy. Oh, sorry, I've been talking all day and I get thirsty so easily. But the area calculations for irregular shapes. What we're going to do is measure a long axis of the area. As we can see here, we've got a distance or length of 47 feet. Then we're going to measure the width at right angles to the length. So we draw this line through it and say, let's say this is a putting green. And so we draw it directly down the middle, we'll come up 47 feet, and then at right angles, we are going to right angles, we're going to take the distance for the width of the putting green. And it looks like they're doing it, here is 6 feet, then they're going to go 4 feet, 5 feet. No, I'm sorry. They're going to be equal distances. Measure the width at right angles to length, make multiple measurements at distances, at equal distances. So whatever that distance is here, doesn't really say. You could set that standard yourself. But then this line A is 10 feet, line B is 16, line C is 20, line D is 25, and then E is 18 feet. So we're going to add all the width measurements and divide by the number of measurements taken to get the average width. So we're going to say the average width, W, is equivalent to A plus B plus C plus D plus E. Add that total, and then we're going to divide by 5. So we have 10, 16, 20, 25, 18 divided by 5 is going to give us 17.8 average. So we're going to take area times length times width. So we have our 47 for this line here. Then we're going to multiply it times the 17.8, and it's going to give us a close range of 836.6 square feet. So you may or may not. I would almost 100% bet that if 3 of my students did this, I would have 3 similar total square footage, but I wouldn't have the exact same one. They'd be really close. Well, here we have volume calculation. We use this primarily for concrete, mulch, topsoil, things of that nature. And it's going to be expressed in cubic units, such as cubic feet or cubic yards. It depends on whether or not you're buying your concrete in the truck or if you're buying it in the bags, or whether or not it'll be stated in square or in cubic feet or cubic yards. But our volume calculations, it is space within a 3-dimensional area. So we're going to talk about it for cubes here. The volume is the area of the base. So we have the base times the height times the width, and that's going to give us, so volume is A times B times H. So let's think about it in concrete terms. We have a patio that's 10 by 10. So we have 10 by 10 square foot is going to give us 100 square feet. If we're going to pour it 4 inches thick, we're going to multiply it times 0.33, which will be 100 times 0.33, and then divide by 27 will give us our cubic yards. If we do not divide it by the 27, it's going to give us our answers in cubic feet. I will upload a worksheet that I have for my students that gives all the decimals for this. It converts 4 inches to decimal point. So if you're not using a calculator, I do recommend, I require this on my course syllabus, is that my students get this, whether or not they do. But it calculates all volumes and everything that they would need for a landscape construction class. Here we have it for cylinder. I'm not going to talk too much about that, but we get into this when we start talking about our greenhouse classes, figuring out volume for containers and stuff that we use. But it's pi r squared times the height. It's the volume of the cylinder. Here we have the cone. It's a third times the large of the base times the height. So you have these right here for your reference. Basically, for landscapers, nurserymen would use this cylinder. Here we're going to be more worried about cubes and rough areas of square feet. It's just like with this thing right here. We can figure out our square feet here, and if we were going to mulch this area at 4 inches height, 4 inches depth or 3 inches of depth, we can figure out if we multiply it by the 0.33 for 4 inches, will give us our cubic feet. Divide by 27, we get our cubic yards, and we'll know how much mulch to get for this project. So here is the next to the last slide, and this is a good example of figuring out volume. A landscape plan calls for a rock fines walk to be installed. So it's pretty much like rock dust pathways. The walk is 6 feet wide and 20 feet long. So that tells me automatically it's 120 square feet. 6 times 20, 120 feet. If the rock fines are 4 inches thick, how many cubic yards will be required to complete the job? Answer: to find the solution to this problem, use the formula of the volume of a cube. So volume is equivalent to A times B times height. So we have the area of the base times the height. Again, it's 120 square feet. Convert the height of 4 inches from inches to feet that you're working. So to convert it to feet, we divide by 12. So 4 inches divided by 12 inches is 0.33 feet. So here we have, again, 6 times 20 times the 0.33 is equivalent to 120 times 0.33, and gives us 39.6 cubic feet. And then to convert it to cubic yards, we've got to divide it by 27. So the 39.6 divided by 27 is equivalent to 1.47 cubic yards. So it would take a truck and a half load of concrete, well, not concrete, of rock dust. We'd go to the quarry and get our rock dust, and we'd get 1.5 cubic yards of rock dust or rock fines. They're not going to give you 0.47. You're going to have to get 1.5. And usually, if you got a good operator, you're going to get a little bit more. So, wow, that concludes this. I said this would be an actual short lecture. Sorry, I do get long-winded, but I love what I do, and I love talking about landscaping and irrigation. There will be a short 10-question quiz on Moodle, and it'll have some math problems like that, and there will be a plan that you'll look at to go with that, ladies and gentlemen. I appreciate it, and I'll see you guys in the next lecture. Thanks.